What's very unique about kind of the way that we look at computational computing is if you guys remember back in '94 when Netscape was one of the first browsers to include the ability to do HTTP security on web pages. That was a trail-setting approach to being able to bring the consumer market into a more secure fashion and to hopefully provide privacy for consumers that are actually sending sensitive information to the internet. But ultimately, it started revamping the way that we look at security. And now, if you think about anything that's web-based now, it is actually being secured with TLS over SSL and being able to protect that information by default. What's really cool about this is as we've expanded into the ways that the internet has progressed for consumers and enterprises, and the whole reason why we exist in these spaces today is to basically make sure that information is readily available to consumers and other businesses so that you can actually collaborate in real time. Now, what's really fundamental about this specific component is when you think about confidential computing, we are in essence, as a industry, bringing the perimeter of the security down to the application layer and being able to protect it for in-use isolation or in-use encryption. And the important thing to know about this is it becomes an enabler for you to revamp the way that you design and architect your networks so that you don't have to worry about the complexities of key management or signature verification. You have an ability to provide an immutable trust in how we actually build these, what we call attestations, around how your applications are fingerprinted and how they work in these environments to be able to provide a garden wall of security around your application and being able to build a effective security posture around specific applications that you deploy in the cloud. Now, what's very unique about confidential computing is you think about traditional security models of building perimeter firewalls, isolating networks. When we look at security from a confidential cloud perspective, it's really focused around the simple fact that we are basically bringing it down to the application layer, providing an advanced firewall through the hardware side of encryption and isolation, and then being able to basically give you an ability to use your application in the most native way possible, but by basically having that in-use isolation and encryption to be able to protect your resources. Now, one of the things that's very unique about confidential computing as a whole, every vendor is going to basically either focus on niche solutions or specific things, but it comes down to two things. One is what I was talking about earlier was really around the attestation or the fingerprints of the application that you're working with. And two is really about protecting in-use. And by having those two components, you build an environment which you can validate, prove, and be able to isolate so that workloads that are running in the cloud or even on-prem can be validated as you're actually processing sensitive information in the cloud or on-prem and being able to protect that information as a whole. Now, what's really great about this is the market is seeing this as a very big and big opportunity to basically change and revamp the way that we're looking at security as a whole, and being able to take a look at how red team and blue team exercises are being run. So, if we look at the CISA, quote, in the way that people are able to basically take advantage of these networks, you think about the latest hack with MGM. Every single time one of these massive breaches happen, it's always based on some type of key being exposed through memory or through, like, let's say, for example, from Microsoft's perspective, having a crash dump that had unprotected keys in clear text and being able to be exfiltrated in a very easy manner. And one of the things that we are specifically looking at is, how do we help these companies that currently have, very isolated networking environments that spend tons of money into these different security applications to protect their actual workloads, and make it possible for them to actually adapt into the native cloud environments. And so, we're basically trying to focus on, taking, infrastructure that typically has never had plans to move in the cloud and being able to help lift and shift into that environment. Now, what's very unique about this is the simple fact that, if you think of, traditional companies in the financial tech space, as COVID has increased the demand for these web-based applications, more financial transactions are happening on these web-based platforms, the more scrutiny regulators are looking at when we're actually providing services to online-based customers as well as business to business. And one of the things that's very unique about this is the simple fact that as we become more mobile with the ways that we operate within the business segment of applications, the more security that we tend to build on top of it. And so if you had a way of basically having a software and hardware level to protect that information as a whole, you have an ability to protect those assets in a very predictable and very scalable pattern so that you don't have to always over-engineer solutions for every different cloud environment, for example. Now, one of the things that we are specifically doing as a company, and this is not specific to my company as a whole, but as an industry, is we have a confidential consortium that really discusses around the different philosophies around key encryption, cryptography, as well as attestation, and how we make it possible so that every vendor has an ability to integrate, to do cross-validation in different environments. And how do we make it easier for customers to move from on-prem to cloud? Well, one of the things that's making this easier for us is a multitude of different CSP providers are investing heavily into these environments. Intel was one of the major trailblazers in the early days with Intel SGX, being able to provide trusted process-level encryption and isolation, and then ultimately moving into where AMD is right now, where they provide secure VM technology for different cloud providers. As well as with NVIDIA and ARM, everyone is going into the space because they see the need to basically be able to provide a basic level of security for their customers and being able to provide it so that it's available no matter where you deploy it into. Now, what's really great about these use cases, and this is something that we get to deal with day in, day out, is the simple fact that we are breaking traditional barriers for security teams who are scared of going into these cloud environments. We're providing a way so that lateral movement doesn't actually happen within these environments if something does get breached. We're actually protecting the most sensitive thing around every enterprise, which is around the key management perspective. And also, how do we actually protect data that's actually being processed and used? Because most applications are not aware or have an ability to encrypt and use and be able to process that data in real-time fashion. And one of the big things that we get to see in the industry today is around people who actually want to get into multi-part computation, being able to not rely on the underlying hardware itself, but ultimately using multiple resources to be able to do that. So we have a lot of blockchain companies we work with that are ultimately trying to figure out how to actually make it more cloud agnostic for their services and not having to rely on that specific information. Now, one quick use case I want to kind of talk about is some of the very generic things that people are using computational computing for. So we actually work with one of the oldest banks in the world. They're basically focused on how to actually get off the mainframe for their environments, but be able to provide a secure and efficient manner so the security teams are not up late trying to figure out if they're being breached by those cloud providers. And one of the things that we did learn about this is computational computing, no matter what it is, provides that enabler that enables you to basically be able to take this information from on-prem, be able to validate when it goes into a cloud environment, maintain the consistency of the application, and be able to provide isolation encryption at all times so that no matter what if a bad release or software release may not have the correct credentialing or the right encryption in there, that it has an ability to basically have a default state. And that's really important when you think about protecting the personal identification information of different environments. The Bank of England actually has what they call the PRA, which basically designates that any type of financial institution that works or has a resident within the UK has to basically protect in use. Same thing with Singapore with their mass regulations. Everything is relying around privacy-enhancing technology services, and that's something that computational computing provides as a whole and gives you an ability to do that. Now, what's very unique about a lot of these problems that we're solving for is the ability to basically take very complex architectures and simplify them. So rather than having a security team re-architect, re-engineer, have to work with another team to basically design this, can be a shared resource between multiple teams by basically getting to the same common goalpost. And that's really what we're trying to do within the computational computing space, is basically making it easier for you to use it. Now, a lot of other things with generative AI, with the ability to basically do process-level encryption, all this stuff is built into the hardware itself. You just need a provider to actually expose it so you can use it natively within the environment. And so we're working with a lot of different types of companies that are working in life science, building data clean rooms, being able to provide actual services that help humankind, but ultimately providing a default level of protection in that environment to be able to build trust and build the ecosystem to validate that this stuff is truly secure. Now, what's really great about a lot of the different ways that we're working with these technologies and as it progresses is the fact that we're giving you an ability to take any type of workload, regardless of how you want to deploy it, and being able to have it adapt it within a confidential manner. And in this specific use case, we worked with a bank that uses a TensorFlow application using Onyx models to basically manage retail processing to verify fraud analysis as well as supply chain, and being able to understand how things are transacting through the process themselves, and being able to do it in an isolated manner so that even with someone with root access has no ability to access that specific thing. As we get into even more complex things where we're actually dealing with DNA resequencing, vaccines, other things, this is very important to basically protect the privacy of people who are actually going through trials, being able to not have to worry about tokenizing this information, but being able to share it in a more secure manner, and then being able to terminate those connections when that validation is no longer valid. And that's what computational computing provides in these different scenarios, because of the simple fact that we want to make sure that these privacy-enhancing technology services don't affect the way that you do business day to day, but ultimately become a very easy button to be able to deploy in these environments. And with the final kind of thought process around this is, if you think about how confidential computing has grown, if you have an Apple iPhone, for example, it's a great example how, from a consumer market perspective, every single application you run on your iPhone is actually in a trusted execution environment. It's in an enclave. It has an ability to basically isolate that process from everything else that you're running on the iPhone. And companies like Apple, for example, are leading that charge to basically show you that you can actually have privacy for consumers, and as well as companies like Anjuna, for example, providing enterprise-level security and making it easier for you to make those deployments happen. If you guys have any additional questions about confidential computing, any more details around the use cases I shared with you, please go and take a look at our collateral we have at our booth, or if you have any questions, definitely ask me after the session. But I want to thank you guys for your time, and I'll have you go to lunch. So.